In this video, I'm going to quickly teach you everything you need to know about the polar coordinate system and show you how to easily plot a point in polar coordinates by walking through 3 example problems. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes where you can fill out the answers to the examples that we're going to do because you can't just watch someone do math, you need to do it too. We'll start by going over the basics of the polar coordinate system. Any point in a two-dimensional plane can be represented in a Cartesian or rectangular coordinate system or in a polar coordinate system. A point in polar coordinates is written in terms of r, the distance from a point to the origin or pole, and in terms of theta, the angle between the polar axis and the ray OP. Theta will be positive if it's measured counterclockwise, and it will be negative if it's measured clockwise. A point in rectangular coordinates is unique, but a point in polar coordinates is not unique. Here we have a point P written in terms of r and theta. Let's look at the angle theta plus pi. We can write our point P in terms of theta plus pi if instead of going forward r units, we go backward r units, and then we arrive at the same point. Our point P can then be written as P of minus r comma theta plus pi. Our point can also be written as P of r theta plus 2 pi if we go around the circle again. There is actually an infinite number of ways we can write a polar point. This point can be written as P of r theta plus 2n pi, where n is an integer, and this point can be written as P of minus r theta plus pi plus 2n pi. Before we dive into our 3 example problems, I want to briefly mention where polar coordinates are used. They're used in situations where describing a point's position may be difficult in rectangular coordinates. This happens with circular motion, graphing circular objects, when working with navigation, in numerous engineering and physics problems, and when working with complex numbers. We'll now do 3 examples where we'll plot a point in polar coordinates and then give 2 other polar coordinate representations of that point. In our first example, our radius is equal to 4 and our angle is 30 degrees. The first step in plotting this point is to plot the angle. We'll mark out an angle of 30 degrees. And then we'll plot the point 4 units from the pole on the terminal side of our angle. This is our terminal side, and we're going to march out 4 units. 1, 2, 3, 4. And that's where our point is going to be located. We'll label our point as 30 degrees. Let's now find 2 other representations of this point. Our first representation can be minus r theta plus 180 degrees. So this becomes minus 30 degrees plus 180 degrees, which gives us minus 210 degrees. Our second representation can be r theta plus 360 degrees. This gives us 4 and then 30 degrees plus 360 degrees, which gives us the point 390 degrees. In our second example, our radius is 3 and our angle is 3 pi over 4. Just like we did for the first example, we'll begin by marking out our angle 3 pi over 4. We'll then march out 3 units and plot our point. Let's now do the other representations. For our first representation, we have minus r theta plus pi, since we're in radians. So this is minus 3, and then we have 3 pi over 4 plus pi, and this gives us a value of minus 3, 7 pi over 4. For our second representation, we can have r theta plus 2 pi, and this gives us 3 pi over 4 plus 2 pi, and this is equal to 11 pi over 4. In our last example, our radius is -2 and our angle is 60 degrees. We'll begin by drawing our angle. And because r is negative, we're going to extend this angle in the opposite direction. We'll now march out 2 units in the opposite direction. So instead of going forward, we're going to go backwards 2 units. We'll start at the pole and go backwards 2 units. This gives us our point. Our first representation can be minus r theta plus 180 degrees. And this is minus 2, so this is 2, 60 degrees plus 180 degrees, which gives us the representation 240 degrees. Our second representation will let be equal to r theta plus 360 degrees. This is equal to minus 2, 60 degrees plus 360 degrees. This gives us a final answer of minus 420 degrees. You should now be able to graph any point in polar coordinates. In the next video, I'll show you how to convert between polar and rectangular coordinates.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.